Imagine yourself standing in the middle of a sweltering summer night in a peaceful countryside, where the sky remains completely unobscured by the dazzling lights of urban areas. The stars twinkle brightly like countless diamonds scattered across a mysterious black velvet canvas, and you cannot help but tilt your head upward, feeling a profound sense of insignificance creeping into your heart as you realize that those tiny points of light represent only a minuscule fraction of a far grander cosmic expanse. This is the very moment that humanity, across countless generations, has begun to pose profound questions about the universe. And today, in the year 2025, even though technological advancements have propelled us farther than ever before into the depths of space, we remain extraordinarily distant from reaching any ultimate destination in our understanding. The very first comprehensive census of stars surrounding our solar system was conducted back in the year 1957, during an era when the entire world was gripped by excitement over the intense space race between superpowers. At that time, scientists could only catalog a modest 915 stars, a humble figure that made everyone feel as though the universe was an immense ocean, and we had merely dipped our toes into its shallow edges. Picture the astronomers huddled in dimly lit laboratories, equipped with primitive telescopes, diligently scribbling notes about faint glowing dots in the sky, the steady scratch of pencils on paper echoing like the relentless heartbeat of unending curiosity. Then, advancing to the 1990s, specifically the year 1991, that number surged dramatically to 3,802 stars within a radius of 82 light-years. This update sparked widespread exhilaration throughout the scientific community, akin to a refreshing breeze sweeping through a parched desert of knowledge. Researchers, with eyes weary from endless hours yet blazing with hope, devoted months and years to poring over data collected from ground-based telescopes, tuned to the faint whispers of the cosmos carried through subtle signals. Now, in the year 2025, scientists possess a vast treasure trove of detailed information regarding the positions, distances, motions, and brightness levels of more than 1.8 billion nearby stars orbiting our Sun. This remarkable achievement stems from the European Space Agency's Gaia Space Telescope, an engineering masterpiece launched in the year 2013. By January of 2025, Gaia had concluded its primary sky-scanning mission after more than 11 years of tireless operation, amassing over 3 trillion observations of approximately 2 billion stars and other celestial objects within our Milky Way galaxy and beyond. Envision Gaia as an indefatigable forest ranger suspended in the frigid void of space, where no wind blows and no breath of life exists, only absolute silence interrupted by endless streams of data flowing back to Earth. Each year, this system catalogs an additional 100 million to 200 million new stars. These figures are not mere dry statistics on computer screens. They represent epic tales of light traveling across millions of years, carrying the essence of distant stellar generations. These numbers, my friend, do more than enrich humanity's repository of knowledge, they dramatically expand the horizons of our imagination. With every passing day, the universe appears vaster, much like an ancient tome whose pages we turn one by one, only to discover millions more chapters awaiting exploration. Despite all these monumental efforts, how much of the universe do we truly comprehend? No matter how optimistic one might be, confronting such immense scale inevitably evokes sighs of resignation, with feelings of smallness surging like waves crashing against rocky shores. Humanity is profoundly insignificant, akin to a single grain of sand on an endless beach, and the starry night sky, once a source of comfort, now serves as a stark reminder of our inherent limitations. What portion of the universe do we actually know? Certainly, what we perceive with the naked eye does not reveal the full truth. Consider a tranquil evening when you gaze upward. The stars seem intimately close, yet science, with its unflinching precision, sharply distinguishes between illusion and reality. From biology, where minuscule cells dance vigorously through your bloodstream, to chemistry, with bubbling reactions in laboratory furnaces, from quantum physics, where particles hover in ambiguous states, to psychology, delving into the shadowy recesses of the human mind, all these fields unveil phenomena and events within the universe brimming with complexity and profound depth that leave us breathless. This realization drives humanity to ask questions, formulate hypotheses, and plunge into exploration and experimentation with burning passion. Over millennia, scholars and philosophers have engaged in ceaseless debates, their voices resonating through ancient stone halls or beneath olive trees in classical Greece, pondering whether life and the universe follow a perfect order or mere random chaos. Scientific disciplines have joined this discourse. We delve deeply into planets with graceful orbits, gravitational forces pulling everything like invisible embraces, atomic theories where tiny particles dictate the fate of the cosmos, relativity with its curving spacetime, and quantum mechanics where probability reigns over certainty. These domains have augmented our comprehension but simultaneously unearthed more mysteries and chaos, like thick fog layers shrouding an already convoluted picture. After striving to explain the world and universe, science reveals numerous limitations, as many occurrences defy description through familiar three-dimensional imagery. Conversely, ancient tales and mystical thoughts interpret the cosmos esoterically, yet none can be empirically proven. Evidently, despite our grand civilization, our knowledge of the universe remains astonishingly scant. Our eyes perceive a dark, empty void, like an infinite expanse where cold mountain winds howl through crevices, but clearly, vast information is missing from such observations. The concept of the universe originates from the Greek word, kosmos, meaning order or world, evoking images of perfect harmony among stars and planets. Often, it encompasses everything, from blooming flowers under morning sun to ferocious ocean storms. In modern science, universe denotes all matter, energy, space, and time in existence. It includes colossal superstructures like spiraling galaxies harboring billions of stars, as well as the tiniest microcomponents like atoms and subatomic particles. Additionally, it encompasses energy, forces, and unknown elements that constitute nearly the entirety of the universe's structure, leaving us feeling lost in a dense forest where every path leads to deeper secrets. Fundamentally, we possess an incomplete framework to describe everything, as no one knows precisely what comprises the universe in full. Humans recognized their existence early. We understood that life on Earth, the Sun, and stars form minor parts of a collective grand structure, like subtle notes in a cosmic symphony echoing through voids. Archaeological evidence reveals that around 8,000 years before the Common Era, humans tracked celestial events like lunar motions to devise calendars. Ancient farmers gathered around flickering campfires, counting lunar cycles to predict harvests, the crackle of flames mingling with nighttime whispers of wind. By approximately 2,000 years before the Common Era, astronomy emerged as a dedicated field, with the oldest sky records attributed to ancient Babylonians. Their cuneiform inscribed clay tablets, now silent in museums, offer vital insights into astronomy and cosmic understanding for Near Eastern and Mediterranean cultures. Notions of time rooted in Persian religion around 8 to 7,000 years before the Common Era later influenced Judaism through Persian conquests. They posited a divine force creating the universe, destined to end with order triumphing over chaos, reuniting all creation with the Creator. Under 1,000 years before the Common Era, in both India and Greece, scholars explain nature via cause and effect laws, engaging in lively discussions beneath bodhi trees or in marble academies, laughter and arguments flowing like rivers. In the 5th and 4th centuries before the Common Era, Greek philosophers debated worldly composition. Some argued for 4 elements, earth, water, fire, air, dancing in primordial chaos. Others proposed indivisible atoms, eternal tiny particles floating in infinity. In India, philosopher Dinaga posited that all matter derives from energy, evoking invisible flows permeating existence. Dinaga, a founder of Buddhism, laid foundations for deductive logic, persuasive reasoning slicing through ignorance like a sharp blade. During this period, Indian and Arab astronomers modeled heliocentric solar systems, while most Greeks favored geocentric views, highlighting how Indian and Arab scholars, though less celebrated, advanced innovative ideas ahead of their time, like torches illuminating paths for posterity. Perhaps from these philosophers stems the modern view that Buddhism grasps the universe more profoundly than contemporary science, blending ancient wisdom with modern knowledge in ways that prompt moonlit reflection. History indeed brims with fascination. Post-Common Era saw Western science rise, with ocean-crossing ships and sky-conquering telescopes. Today, modern science elucidates everything: matter with hefty masses, energy in ceaseless flows, life in birth-death cycles, and the universe under immutable laws. Of course, limitations persist, yet modern science has elevated civilization through geniuses like Copernicus revolutionizing heliocentrism, Galileo crafting telescopes, Newton formulating universal gravitation, and Stephen Hawking pondering black holes and time. Thanks to them, cosmic mechanics yield calculable galactic masses and celestial velocities without direct verification. Formulas from relativity to quantum mechanics, astrophysics to black holes, fill thick tomes. You read them to grasp the universe's basic operations, like a colossal machine with precisely geared cogs ticking every second. Yet, with all this, how much of the universe do we know? Decidedly less than 1%, even 1% overstates it. Scientists estimate ordinary matter comprises 5% of the universe, dark matter 26.8%, and dark energy 68%, accelerating expansion, per the updated Lambda CDM model in 2025. The remaining 95% remains unknown, and remember, even the 5% is hypothetical, not certain. Setting aside that 95%, within the remaining 5%, our grasp of truth is shockingly minimal. We lack exact counts of Milky Way stars, observable universe galaxies, or whether the observable universe encompasses all. We dare not assert definitively. Consider light as a simple example. Observing or photographing any star, naked eyes detect visible electromagnetic radiation spanning radio waves to gamma rays. Yet, humans perceive only visible light, rendering all other electromagnetic spectrum data absent, like viewing a painting with mere outlines, missing vibrant colors. We observe an infinitesimally small universe fraction, mostly lacking essential details or invisibly complete. The universe likely flaunts secrets lavishly, but our capacities fall short, like a child reaching for ocean waves yet unable to embrace the sea. While enjoying science-enabled modern lives, pride in intellect or cosmic achievements, parallel worlds in other dimensions may exist unbeknownst, overlapping realities like dream mists. Ultimately, what percentage of the universe do we know? A question hanging like a lost star in the night sky, beckoning continued journeys. Since humans invented writing to record history, or even before, conflicts and wars have persisted unrelentingly. To this day, nothing changes. Earth spins amid starry vastness, yet people fight over it, seemingly an innate human trait, a lingering sorrow threading eras. No matter what we say or do, this characteristic may endure until humanity vanishes from the universe, a chilling prospect under reality's drizzling rain. This is not primarily a war tale, but revisiting history illuminates today's world, like flipping aged pages scented with yellowed paper. Formerly, battles centered on land grabs, bloody fields with clashing swords thundering like storms. Eventually, realizing conquests yield no extra land, powers shifted to resources and energy. Our South China Sea exemplifies, lush islands amid azure oceans fueling ambitions. Yet, fossil resources offer short-term fixes, like candles flickering against gales. In 1969, America landed humans on the moon, a historic moment halting the world breathlessly before black and white screens, billions hearts pounding. Instantly, the moon emerged as tomorrow's gold mine, rich in resources like hydrogen, helium, oxygen, iron, silicon, aluminum, titanium, germanium, gold, rare earths, glistening minerals buried under gray dust for billions of years. Recent decades saw numerous lunar orbiting satellites conducting science while surveying resources for ambitious projects, details guarded by major powers. The moon stands as a strategic target in centuries-long development roadmaps, a new horizon echoing machinery in silent vacuum. From 2013 onward, nations like China, United Arab Emirates, and India invested heavily in lunar exploration, blending science with carving shares of this lucrative pie. In 2021, America allocated over $23 billion to space exploration. By 2022, nearing $25 billion, accelerating launch vehicles and moon returns via Artemis and Orion spacecraft by 2024. Anything lunar holds value, from metals to ordinary rocks, even dust producible into oxygen for rocket fuel or habitat air. Imagine astronauts in bulky suits breathing dust-derived air, pumps humming in silence. Lunar surface regolith mirrors Earth's, containing 45% bonded oxygen with minerals and metals, chemical reactions and electrolysis extracted, remnants fueling construction. European scientists recently proved high feasibility, though energy-intensive, 2 to 4 megawatts annually for 1,000 tons oxygen. On Earth, unnecessary with trees freely providing abundant oxygen, green canopies whispering life breath in breezes. Beyond metals, the Moon harbors precious helium-3, ideal for nuclear fusion reactors, lower input energy, higher efficiency, minimal radioactive waste. Earthbound helium-3 is rare, comprising 3 parts per billion in atmosphere, extraction costly. Solar winds deposited about 1 million tons helium-3 mere meters deep in lunar surface, heating to 600 degrees Celsius extracts it. For scale, 25 tons could power America entirely for 1 year, priced at $3 billion per ton. Among priciest lunar resources, by 2025, startups like Interlune lead extraction races, planning 2027 missions for helium-3 concentration mapping and small-scale tests, pilot plants by 2029 supplying quantum firms like Mabel Quantum. This explains nations pouring fortunes into space. Additionally, vast rare earth deposits, critical for medicine, electronics, weapons, materials, though scarce, essential and expensive. China controls 95% global production. The Moon offers independence, especially as Interlune eyes post-helium-3 industrial metals and rare earths. Which nations claim lunar resources? Economics largely decides. Poorer developing countries, even granted access, lack capabilities. This race suits superpowers with vast budgets and fierce ambitions. The 1967 United Nations Outer Space Treaty declares no nation owns the Moon, yet questions arise on enforcement. Nations land robots, plant flags asserting sovereignty, unstoppable, with capability, Vietnam would too. Regrettably, we watch others on cozy living room televisions, announcers' voices booming. Exploitation impacts. Simple calculation, Moon mass 7.3 quadrillion tons, daily 1 ton extraction takes 220 million years for 1% loss. Scaling to hundreds, thousands multiplies to millions years, negligible tidal effects, waves lapping golden sands unchanged. Greater concern, Earth's environment, polluted city clouds, blaring horns reminding nearer issues, not lunar activities decades hence. Moon receding? Annually 3.8 centimeters, insignificant alone, but cumulative worrisome. Vital satellite influencing landscapes and life, full moons illuminating villages, insects chirping under silver glow. NASA experts confirm Earth's rotation causes this. Post-solar system formation, Moon as Theia asteroid remnant, early Earth spun twice faster, Moon closer. Collision added large satellite slowing rotation over time, Moon drifting outward, though plate tectonics significantly contribute. 1.4 billion years ago, Earth-Moon distance under 340,000 kilometers, now 384,000. Current drivers, plate movements altering ocean shapes, depths, friction slowing rotation, affecting tides and recession. Lunar departure stems purely from Earth's dynamics, unrelated to mining. Live millions years to witness changes, now, no worry, Moon shines beautifully as ever, faithful companion hanging eternally. Throughout most human existence, scant tools observed measured cosmos, their eyes gazing in primal awe. Today, scientists debate universe finiteness versus extreme largeness, infinity versus bounded vastness, fundamentally altering comprehension, like boundless dreams versus fenced gardens. Observations suggest flatness, parallel lines from any point remain parallel forever, supporting potential infinity, yet flatness doesn't necessitate it. Humanity recent on Earth, universe nearly 14 billion years old, most past events unwitnessed, current happenings unknown, secrets whispering in time's darkness. Universe began tiny, expanding ceaselessly, yet infinity expanding. Better, expanding toward infinity, endless process, not already infinite. Suggests finite yet boundless space, no edges surfaces. Universe material, ultimate boundary. Imagine bubble filled with galaxies, stars, objects, external view like astronauts eyeing blue Earth from International Space Station. Yet universe may lack outer surface, inflating balloon without shell, or expanding smoke cloud dissolving briefly. Does space-time dissolve externally? Composition? Mostly hydrogen-helium, classified as galaxies, stars, planets, moons, comets, asteroids, nebulae, cosmic dust, diverse yet natural law-abiding, 5% total. Rest, dark energy, dark matter, space-time. No precise answer, too many unknowns. Observations uniform everywhere. Expanding smoke dilutes density, universe expands without property changes, space-time qualities constant. Like balloon inflating internally unchanged, but not closed, external air pumped, shell separating. Our universe similar? Not closed, extra space-time infused somewhere, implying boundary membrane. Observable universe over 93 billion light-years, perhaps tiny actual fraction, tech limited. Anywhere beyond solar system, similar views, universe isotropic, homogeneous. Unknown true size means undefined endpoint, boundary appearance, transparent membrane. External existence? Stephen Hawking, universe from nothing, rendering boundary questions nonsensical, no inside, outside for all-encompassing. Spacetime integral, nothing exists sans it. Pre-universe observer imagining creation positions externally, impossible without spacetime. Einstein, finite yet unbounded, curved space looping travels like Earth circumnavigation. Current flat measurements, not whole universe, boundary unresolved. 2008, astronomers detected strange mass cluster pulling Milky Way over 3 million kilometers hourly, insane for such mass. Hypotheses, dark flows, colossal influencing multiple universes, or bubble within larger, gravities interacting creating bigger. Others, four-dimensional external twisted, our three-dimensional observation blinds externals. Likely bubble among infinities. Hard knowing externals or timeless existence, universe growing implies bounds, unimaginable geometrically, beyond human grasp. Disregarding scientists, philosophers, theorists, personally, universe bounded with externals, perhaps simulation, sleepless nights staring dark ceilings wondering dreamlike reality. Post-Soviet Sputnik 1957, Mao Zedong declared China satellite building, echoing halls with rising nation aspiration. Over a decade later, 1970, first orbital success. 2003, Yang Liwei aboard Shenzhou 5, third nation independently human spacefaring, cheers erupting control centers, engineers beaming sweat-wiped smiles. Recently, China economic space superpower, seamless Moon-Mars missions. April 28, 2021, Tianhe module launched, independent station ambition, completion 2022. Video explores billion-person nations' cosmic conquests. 5,000-year history famed internally warring, scant global science contributions, now transformed, rapid development despite global disfavor. 60s, 70s, amid US-Soviet rivalry, secret Shuguang spacecraft for 1973, politics economics indefinitely delayed. 1999, Shenzhou 1 test. 2001, Shenzhou 2 animals, dogs, rabbits, seeds, 200 days life support testing, South Atlantic landing, international media suspected failure, China denied. March 2002, Shenzhou 3 dummy human tech. December 2002, Chenzhou for prep. 2003, Yang Liwei 14 orbits, Pride surging wave-like. 2005, Chenzhou 6-2 astronauts days, 75 orbits. 2008, Chenzhou 7-3, first Chinese spacewalk, chilly void steppes, breaths MIC echoing Earth. 2011, Chenzhou 8 Tiangong 1 docking, initial station effort, to 2016 uncontrolled reentry. 2012, Chenzhou 9-3 including first female, spaceflight. 2013, Chenzhou 10 second female. September 2016, Tiangong 2 lab launch. October, Chenzhou 11-2 docked, longest Chinese duration. April 2017, Tianzhou 1 cargo. 2018-19, controlled Pacific reentry. Beyond orbits, planetary missions Moon, Mars catching Russia, America. April 28, 2021, Tianhe orbit, permanent station core, Wenchang Center, Hainan, long march rocket 18 meters, 24 tons. Post-launch solar panels deploy, booster orbits days then falls. Xi Jinping, immense pride, strategic science, tech, space powerhouse step. 11+ missions ahead completing Tianhe, human habitation like International Space Station. T-shaped, 70 tons, 450 kilometers altitude, smaller than ISS, expandable 10 modules, decade-plus operation. Unlike NASA openness, China secretive, launches, parameters guarded, known info uncertain. Europe-UN plans scientific cooperation, America reluctantly seeks congressional ties. Upcoming, Tianwen, 1 Mars landing post-July 2020 launch, March 2021 arrival orbiting. June, Chenzhou 12-3 docking Tianhe. 2022, additional modules. 2024, lunar possibly crewed. Stable cautious progress, avoiding US-Russian failures. 1-2 decades, matching Russia-America aerospace. Many replicate San's innovation, rapid advanced tech acquisition centuries earned. Decades ahead thrilling with SpaceX, Blue Origin breakthroughs. Criticize, dislike China, including me, yet acknowledge rapid progress surpassing regions, continents, we lag far. Long secrecy successes, failures reveals vast ambition, soon solar system dominance, centuries nurtured multi-leader resolve. Tech origins irrelevant, effective. Vietnam, high-level space plans? Finally, despite China's strength modernity, parasol spratly Vietnam's, simple steadfast mountain amid seas. What 3-dimensional, 4-dimensional, 5, 6, 7, 8+ dimensions? Complex abstract, start simple. 1 2-dimensional, flat plane, no depth, fixed angles, 1 straight endless shorten line, 2 adds directions, angles, shapes. 3-dimensional, depth, width, multi-angle views, our world invisible boundless container holding energy, matter, phenomena, objects. 4-dimensional, Einstein relativity, time physical inseparable from space. We live space and time simultaneously. Universe bubble-filled space-time, not detachable, hence space-time. Time invisible, non-interacting, no particles, radiation, inescapable ruler humans, stars, atoms. Prove relativity wrong if time mere human sequencing concept. 4-dimensional, daily perceptions. Higher dimensions. Post-Einstein relativity rescued centuries impasses macro phenomena, insufficient micro. Physicists, mathematicians hypothesize formulas, dead ends add dimensions reviving accuracy. Aim, explain subatomic particles, forces relativity ignores. Beyond 4, string theories, particles from mathematical, strings, vibrating differently. Strings Planck length 1035 meters. Decades effort unifying forces, particles complete picture, 5 variants merged M-theory requiring 10, 11 dimensions. Post-4 curled, compactified with time, invisible. 5th, alternate worlds. 6th, world's origins time travel. 7th, multiple worlds starts. 8th, creation branching source. 9th, history, destiny weaving. 10th, all-encompassing beyond imagination, even creators. Daily ghost, soul sightings hint higher dimensions, fleeting mirrors, whispers goosebumping, not universal, science unexplained. String higher scientifically mathematical, unprovable, unfalsifiable yet. True, universe simulation algorithms, ray owl shapes differ perceptions. 5-dimensional black hole simulations donut bulging unlike known, interstellar 5-dimensional tesseract viewing interacting pasts. Higher speculative, films, imaginations hypothetical, unconfirmable, undeniable. Imagination birthing worlds, 20 dimensions. Parallel Earths collapse knowledge, universe computer simulation multiple programs worlds, humans virus, overgrowth crashes or antivirus ends, bitter screen smile wondering code in someone's dream.